This video is a supplement to PVT relation in lecture 1 of topic 4. How does volume of a gas vary with pressure? Consider a balloon inflated with air. If you squeeze it in your hand, you can make it smaller in size while the pressure of air inside it tends to increase, so we say volume and pressure are inversely proportional. That means when the pressure increases, volume decreases. How does volume of a gas vary with temperature? Consider the balloon inflated with cold air in a cold room. Now move to a hot room. The size of the balloon should become a little bigger when temperature of the air inside it goes up. So we say that volume is proportional to temperature. That means when the temperature increases, volume increases with it as well. How do the relations lead to an equation of a state for gases? So we found those proportionalities earlier. We would like to use it in order to have an equation of a state for gases. An equation of a state is one that defines the relationship between pressure, volume, and temperature of a species. So PVT relation is defined through an equation of a state. We found that volume and pressure are inversely proportional, or volume is proportional to 1 over P. And also we found that volume and temperature are proportional to each other. We can combine these relationships and say that volume is proportional to T over P. To make the proportionality an equality, we need to multiply one side by a constant. Therefore, we can write volume is equal to a constant like K, T over P. We can write this equation in the form of P times V equals to K, T, where K is a constant. This constant is related to the volume. It means that if we have a bigger volume, then constant K would be bigger. In order to make the constant independent of the size of the balloon or independent of the volume, we can define a universal constant like K is equal to nR. This R is a constant that is independent of the size, and N is the number of moles. Therefore, we can write the relationship as PV equals to nRT. This is called equation of state for gases or ideal gas law. If we take this N to the denominator of here, it means that if we divide the equation by N, we will have PV over N equals to RT. So this is the form that we arrived at. This is another way to write the ideal gas law. V over N is called the specific volume or volume per mole. Specific volume is denoted by V hat, so another form of writing ideal gas law would be P V hat is equal to RT. The units of V hat would be like foot cube per pound mole or liter per mole. So it's a volume over number of moles.